All right. So in our last unit here, okay, we're talking about global systems and energy. So we're trying to kind of work everything we've talked about into one thing, right? So we're trying to tie them all together, all right? We talk about lots of different forms of energy, obviously, okay? We also talk about how that affects life on Earth. So there's a little bit of the biology stuff in there. And there's a bit of stuff about energy in like phase changes of water, which is kind of a physics, but kind of a chemistry thing. It's really about the only thing in this unit that carries over into any other science course, right? And that it carries over into chemistry, right? Into Chem 20 and Chem 30. Okay, so we look at specific heat capacity, that is how much energy is required to heat something up, and we look at how much energy is required to melt ice or evaporate water and things like that. So it's kind of part of the water cycle and things like that. So there's not nearly as much material in this unit as there is in the others. Okay, that's a good thing. Right? Because A, we don't have time for a full unit, and B, it means that there's less to learn for well, not just for the final, but also for this unit's unit exam. Okay, this unit's unit exam covers less material. That means it's easier to master the material and do well on this unit exam because there's less material to master. Everybody follow me? Now, here's what I want you to take away from that. This is an opportunity to raise your mark before the final. Mr. Coder is not saying this unit is easy, don't study. Mr. Coder is saying this unit is easier, study hard and do well so that your mark goes up before the final. Okay, and I'm not saying that the final is all doom and gloom. Okay, it's not going to be awful like The Last Jedi, but yeah, it's going to. Yeah, I did. I didn't spoil it. I didn't like it. Anyway, so the final exam is not awful. You've seen everything on it already. Okay, that's why it's a final, because everything on it you've already done. Okay, and none of it is as hard as I've asked in previous stuff. So. No, because that's garbage, actually. Yes, I totally disagree with that. And in fact, we would get in trouble if we were to do that, because it essentially says all your classwork throughout the year was meaningless. And I don't believe that. Yeah, I believe your classwork was very important. So no, we won't do that. And no, you don't get an exemption if you have a certain grade going in. That's also, yeah, not realistic. So you're all writing it. Deal with it. What's that? Oh, well, that's okay. We'll bring it to you. Yeah. Then you write it later. Yeah. I would suggest, if at all possible, yeah, I mean, obviously, if you have like a severe injury or something like that, exceptions are made. But, if you're just, oh, my stomach hurts a little bit, suck it up and get in here and write the test. Okay. Because you don't want to have to write it later, because A, not the same test. Okay, because I can't give you the same test to give everybody else on that day, because the security of that exam is compromised. Okay, and secondly, that if it's significantly later, you're not going to remember that material. We've had people who've had to write their final months later, like at the next writing of the final exam. So like in June, like you're not going to remember the stuff you learned in September and June. You have all these other courses that you're taking this semester. That's not a recipe for success either, right? So yeah. If you got a headache or your tummy is a little upset, suck it up, Buttercup, and get in here and write the test. Yeah. All right. You got a gaping head wound, go to the hospital. Don't write your test. Okay. Yeah. Common sense stuff, right? Okay, you get it stitched up and get in then. Yeah. Okay. All right. So key points. We got to look at the components of climates. Okay. So components of climate, basically, what are the parts of climate? What are the things that contribute to it? Okay. We're going to look at the factors that affect climate, because obviously climate is different everywhere. What is climate? Weather. Okay. Not just the weather. The weather is the weather. Like today, it's snowing, which is nice. Okay. That's not the weather all the time. That's not the climate, okay? The climate of Canada is not snow, unless you live in the States where they think we live in igloos and stuff and have dog sleds. But, okay, that's not climate. Our climate is the prevailing weather or the expected kind of weather, given time of the year in a given location. It's very specific. Okay? If I said the climate of Okotoks is that the average temperature is 6 degrees Celsius, winds are from the southwest at 25 kilometers an hour, and there's about, let's say, a quarter of a millimeter of precipitation a day. That's not describing the climate here, is it? That's averages. That's not predicting or telling people what it's like here. I mean, if I told people that it's 6 degrees here, the climate here is 6 degrees, they're going to go, wow, that sucks. That's cold. Okay? It's not. I mean, sometimes it's colder. Sometimes it's much hotter than that. Okay? What we would describe are some of the various factors and what they typically can look like, including that weather changes here. Right? I mean, we have a saying in Alberta: if you don't like the weather, wait 5 minutes. Okay? Because weather changes here all the time. Right? So we can't give like a fixed description of what the climate is like. Now, some places in the world can you do that? Yes, like being a weatherman in Hawaii has got to be the easiest job in the world. Okay, been to Hawaii a few times, and every time I go there, I flip on the weather the first day, look at it, and go sweet, and turn it off. I never have to look at it again because it's the same thing every day. Okay, it's going to rain a little bit. It's going to be a little bit windy at some point during the day. It's going to be about 30 degrees Celsius, and the wind will come up. And it's the same. Like the weather guy just has to like put that up and walk away for a week. Right, and then come back. It's got to be the sweetest job ever, and he can't like he's rarely wrong. Being a weatherman in Alberta is challenging because you're wrong all the time. Okay? Much different thing. All right, we're going to look at the effect of climate on plants, animals, and humans. Okay, and we're going to describe the energy inputs and outputs of various environments. Probably won't get that today. And then we're going to look at what climatograms are, because that's kind of how we're going to finish up before Christmas, is working on what's a climatogram, what can it tell me about the prevailing weather at a location. All right, so climate. Definition of climate is the prevailing weather conditions at a location. Not the weather on a particular day, but the prevailing weather. What is it likely to be like? The main components of that, okay, the things we look at as parts of climate are temperature, precipitation, light, and wind. And these are typically the things that you would get in a daily weather report, right? Like if you open up the weather network or the weather app on your phone or whatever, those are the things it tells you. It tells you like sunrise and sunset, or it tells you how many hours of sunlight are expected. It tells you whether it's going to be cloudy or not. Okay? It tells you the temperature. Obviously, that's kind of the big thing we look at. And second to temperature is probably how windy is it going to be. And then is it going to rain, snow, hail, or be clear? Okay, so those are the four components. Okay, Jake, your question? Yep, that's definitely, that wind is a general thing, but yes, the nature of the wind is, yes, a consideration. Generally, where does our wind come from? Yeah, from the mountains, right? Southwest, okay? That's typically where our prevailing winds come from. We know, like yesterday, the wind came from the north. What does that usually signal? A change in the weather. Okay, you guys got to be more tuned in here. Okay, yeah, it's whenever we get a wind from the northeast, it means a change is coming, because that's not typically where the wind comes from. When it comes from the southwest, it typically brings the same kind of thing, warm air masses, right? But if it comes from the north, it's bringing cold air from the north. Yeah, not as much now as it was about 5 minutes ago, but we're in Alberta. So if you didn't like the snow 5 minutes ago, guess what? Okay. But it'll be off and on like that. We're supposed to get like 30 centimeters by Wednesday afternoon. So yeah, White Christmas on the way. You're welcome. I ordered that. All right. So looking at precipitation, okay? Is it generally fairly dry here? Yeah, we live in a fairly dry climate. It's not arid, okay? Not arid by any sense. We don't live in a desert, but this is a fairly dry place. Okay. But is precipitation like we get a certain amount every single day, or is it patchy? Yeah, it's a bit patchy, but are there wetter times of the year than others? Okay. From your experience, what's typically our wettest month? June, July. Those are our two wettest months. June and July. Snow, here's the thing about snow. It looks like when we get snow, we get a whole bunch of precipitation. But 10 centimeters of snow equals 1 centimeter of rain. Okay? There are times in the summer, in June and July, when we get those big thunderstorms, where we get that much, right? Where we, well, not 10 centimeters, but we get like a centimeter of rain in an hour, right? It's gone. Right? It just comes through. Or we get one of those big hailstorms where we get like 5 or 6 centimeters of rain, right? Like when we got the hail there, not last year, but the year before in June, right? Where that huge hailstorm, and it looked like there were snow drifts down by Costco, okay? Because all the hail had washed down into that area and plugged the drains, and it wasn't melting quick enough. So yeah, we can get large amounts of rain, but our wettest months are typically June and July. This year, obviously an exception to the rule. How much rain did we get in July? Yeah, I think it ended up being like 9 millimeters, okay, in the month of July. Right? It was like the driest July on record or something like that. It was hot and dry. Okay, June wasn't all that wet either. Okay, this was a very dry year, but typically June and July are our wettest months. In 2013, we got more rain than was ever had on record. Okay, June was the wettest month ever that year, okay? And that was awful. Okay, so precipitation, yeah, when we describe the climate of an area, we talk about the precipitation patterns, not an average daily amount of rain, because that's not an accurate description of what the climate is like. So if I was describing the precipitation pattern in Okotoks, I would say that it comes in many forms. Okay, it could be hail, it could be rain, it could be snow, we get it all. Okay, and typically the wettest months are June and July. We get a really kind of dry tendency towards fall. Okay, and then things kind of pick up through when winter starts, December, January, February, we get a fair amount of snow. Okay, March, it can be fairly wet as well. May tends to be a little drier, then it picks up again once the thunderstorm cycle starts up. So that's how we would describe the climate here, okay, at least in terms of precipitation. How would we describe it in terms of light? Right, because of our latitude, light changes. Our day length fluctuates wildly. Okay, like right now we're approaching the shortest day of the year. Right, I mean when we come to school, the sun is just starting to creep over the horizon, and on our way home, we're looking into a sunset at 3:30. Okay, so yeah, we're getting on the shortest days of the year right now. We're looking at somewhere between 6 and 6.5 hours of daylight. Okay, which is nothing because right now, if you live in Alaska or Iceland or any place that's kind of in the Arctic Circle, they are in what they call the dark days. They'll go, I think it's 63 days without a sunrise. Okay, like it's crazy. Okay, but at the same time, in the summer, they go 63 days without a sunset. Okay, which is awesome. If your parents tell you, "Hey, come home at sunset," you're like, "See you in August." Okay, and come back. Yeah, but yeah, it's a lot different. Okay, the sun actually in the Arctic Circle just kind of goes like this during those months. It doesn't set. It just kind of circles because they're tilted towards it, right? What do you mean always at the same light level? Yeah, kind of. I mean, there's a bit of a fluctuation. I mean, but it's generally, I mean, it's still more directly overhead than, so it's not like perfectly overhead. It's like near the horizon and then overhead, near the horizon, overhead. Yeah, it's weird. Okay. All right. And then for wind. Okay. Obviously, wind here. I mean, we're not the windiest place around, but it's pretty windy here. It's not like Lethbridge. Okay, but it's certainly windy, and the wind typically comes from the southwest. Okay, and we could also mention that we have special wind patterns called Chinooks. Okay, that's something Leonardo DiCaprio should have learned before he came here and opened his big fat mouth. Okay, yeah, because he's an idiot. I'm going to post that on YouTube. He's an idiot. Okay, because he watched climate change happen in 20 minutes. He also doesn't know what climate change is because climate change is a long-term change in climate and weather. He saw a Chinook, and we're all like, "You are such an idiot." Yeah. Okay. Go home. Go back to California where you pollute the whole world and complain about us. Yeah. Anyway. Okay. So that's what we got there. Those are the big things, and then obviously temperature. What would we say about temperature in Okotoks? Well, I mean, but it changes, right? It follows the light pattern. Our coldest days are typically in the wintertime when we receive less direct sunlight. Okay, so it's going to be colder. We have distinct seasonality, right? Yes, it can be very warm, but it can also be very cold. All right, so all of these factors interact, obviously, to produce the weather that we experience on any given day, right? In the summertime, sometimes we see these. What is this? What kind of cloud? A cumulonimbus cloud, right? Okay, this is the kind that makes thunderstorms, right? It is the interaction of all of these components, right? Typically, you get thunderstorms on what kind of days? Hotter, humid, and no, not usually till it starts, okay, till the storm starts. But usually it's fairly calm because a wind will tend to disrupt the process if there's a lot of wind. There's obviously exceptions, but most of the time it's a fairly calm, hot, humid day in order to build this. Okay? This requires a lot of water to evaporate from the surface of the earth. Okay? And then what happens is it starts to build up, and as it goes up in the atmosphere, the temperature gets colder, and eventually that water vapor will condense, part of the water cycle, right? So it condenses, and when it condenses, obviously liquid water is heavier, and so it's not being lifted by the air current, so it starts to fall back down. But on a hot, humid day, what ends up happening is you get so much hot water vapor filled air moving upwards that even liquid water can be suspended in the air. And so what it starts to do is cycle through the cloud. So you get water vapor goes up like this, and then it condenses and it starts to fall back down. But there's so much of this updraft that that water vapor can be pushed back upwards, and usually it gets pushed a little bit higher. And the next cycle through, a little bit higher. Okay, and the next cycle through, even higher, till we start getting the clouds to get really, really tall and flatten on the top. Okay, the more times it goes through this cycle, the bigger the droplet will get, because other water vapor will condense around it and they'll get bigger. If it goes through that cycle enough times, eventually it'll start to what? It'll freeze. And then it becomes hail. Now, the hail cycle really gets going because now you've got this cold piece of ice moving through that cycle, and any water vapor that hits it immediately condenses on it and freezes and makes the stone bigger. That's how they grow. The more times they go through that cycle, the bigger they'll get. Anyone ever cracked open or cut open a hailstone? You can actually see the layers inside a hailstone. Okay, you can see how it's grown and gotten bigger. Depending on the clouds. That's why they have so much radar data, and they shoot lots of radar at the clouds, and they can tell whether it contains ice or not. And yes, they will fly around it, but not just because of the hail. I mean, hail hits a plane, the plane gets dented, right? Big deal. It's actually not as big a deal for the planes because they're higher up and it's not moving as fast, right? It hurts more on the ground. The bigger worry for the planes is the radical changes in direction of updrafts. That's turbulence, right? And if they get suddenly hit from one side, or something like that by a big updraft, that can cause the plane to crash or damage the plane or whatever, right? So that would be more the reason they would fly around. Lightning strikes, also a concern. You don't want to fly into something where there's lightning going around. That strikes the plane, that can be a problem. So, well, if it's not properly insulated or shielded, then it can fry the electrical systems, and plane kind of relies on those. Yeah, yeah, yeah. Because I mean, the planes, like the flaps and stuff on those, that's hydraulic, right? So that's an electric pump that moves the hydraulics that move the flaps. If that goes out, how do you steer the plane, right? So yeah, so anyway, that's the hail cycle. Okay, the more times it goes through there, the bigger the hailstones will get. So those hailstones we got there back in 2000 and was it 15? Okay, then we got the really big ones. Those had obviously gone through the cycle a number of times. Okay, those were fairly bad. They were, decent golf ball size, or maybe a little bit bigger than golf ball. Okay, there was a storm in Wainwright in 2005 where they had grapefruit sized hail. Okay. Oh yeah, absolutely. Like at windows, everyone's roofs had to be replaced. The car dealerships had brand new cars that were totaled. They were completely destroyed. Like here, when we got that bad hailstorm, the car dealerships would either sell them off at a loss, or they would get them fixed, right, and then sell them and say, well, it was damaged, but it was repaired. These cars were total write-offs. There were holes in them. Okay, like all the windows were broken. They could not be repaired or sold. They were scrapped for parts. whole inventories of that year's cars in Wainwright were completely written off. Nope, no, because this happens right over top of us. We build a thunderstorm, it happens over land. Nope, no, starts here. Well, you'd be surprised how much water vapor is actually contained in plants and in the soil and stuff like that. Quite a bit, right? And it collects and then it moves to another spot, right? Like the rain that we get didn't necessarily form right over us. It could have been over Strathmore or over Brooks or where, well, probably not Brooks because it tends to go that way. But you know, it's around here. When we get a long-term rainstorm or this snowstorm that's coming, that's the result of moisture coming from the ocean, right? So we've got a warm air mass coming in from the ocean coming up through Montana actually, and a cold air mass coming down to meet it. When they meet, that's when storms happen. Okay, we will leave it at that and we'll pick up with that tomorrow.